Hello, everyone. Welcome to the session. This is a special series that we have started, wherein we are going to explain on every Friday from 6 p.m. to 7 p.m. IST about a project that we would have accomplished in the past. And we also aim to explain the projects end to end, right from understanding the business problem until deploying the solution in production, and then monitoring the model for retraining the model. Right? These are the various things that we will be doing end to end. And we will be understanding each component of it in a specific detail. Certain projects will spill over to 2 weeks. For example, this project that we are understanding now would happen today as we are speaking now. And it would also happen, next week. So first part of it would be understood today, and second part would be understood next week. All right. And this specific project is about monitoring the electricity consumption within the space of beverage industry. Okay, and that is what we are going to understand.
I think I would need co-host access. My dear friend, I connected via mobile as well. It's fine with me. Sendel?
Yeah, sorry for that slight glitch. Okay, so this is a project that we have done for one of the beverages company, which is considered to be one of the gold standard players in the space of beverages. You can guess it out because we have two major players in the space of soft drinks, and this is done for one of those companies. And here we were asked to look at electricity consumption. We were asked to do prediction on how much electricity would be consumed across the entire plant by capturing the data through IOT sensors. So we use Internet of Things, which is an electrical or electronic component, which would be installed on certain locations, and then it would be capturing electricity information or power information, how much power is being consumed by various machinery. So let's get started. Here is the agenda. We would be understanding the project overview and scope, objectives, constraints, crisp MLQ methodology, which is widely adopted currently to handle any data related projects. It could be data science related, or it could be artificial intelligence related, or it could be data engineering related, any of the data related projects that you handle. Majorly, people are employing crisp MLQ methodology. Then we'll understand the technical stack. What were the various technologies which were used in accomplishing this specific project? You will also understand the project architecture. What were the success criteria which were defined at the beginning? I would say business success criteria, technical success criteria, economic success criteria, etc. Those are the things. And then we will understand how data was collected, how did we try to understand more about the data, how did we actually build the model, how did we select the right model, how did we deploy the model in production. There is one more very important phase, which is called as model monitoring and maintenance. Model monitoring and maintenance. Of late, there has been heavy emphasis on how to deploy the model in production and how to perform model monitoring and maintenance. There has been heavy emphasis on this. Hence, we started off this series because until now we would have accomplished easily 100 plus projects. Out of that, our participants have worked on approximately 68 projects or so. So we have picked up 50 projects out of that. And we will ensure that every Friday, we drive you through the journey of one of those projects end to end. So no longer you need to, worry about how the model is built, how is it deployed, how do people use that model. You need not worry about that because the moment you attend each of these sessions, you'll be learning new things. Okay. So the project overview is as follows. The project would focus on monitoring the power consumption, how much electricity is consumed in beverage industry. Without naming the name of the client, it's one of the gold standards. So it's anybody's guess. And monitoring the electricity consumption has to be done via IoT sensors. So Internet of Things, a sensor, Raspberry Pi, industrial grade Raspberry Pi, or Arduino, Node MCUs, certain devices are used, which are of industrial grade because you cannot use the one that you use for your experiments at home for production. And then those IoT sensors were installed on the various machines which which use electricity. Right? And it has been observed that most of the power consumption depends upon the electrical motors. Electrical motors are installed across various units of the beverage plant. So this project will work with the data associated with it. So for example, you'll have a unit which is called as a blower unit. What happens in a blower unit is, blower unit would take preform. Okay, it would take preform as an input. Preform is like a small glass substance, which has the property to expand if you blow air into that. So in the blower unit, air is blown into this preform. If more air is blown, it would result into your 1.5 liter PET bottle. You purchase, right? You purchase Coke, Pepsi, etc., 1.5 liter. Or you also might want to purchase 500 ml. If you need a 500 ml bottle from this preform, then less air should be blown. If you want 200 ml, even lesser air should be blown. If you want 2-liter bottle, then more air should be blown. So the air pressure has to be monitored. Okay. And then what happens? From here, once the bottles are blown to the appropriate size, they go into, or the process includes chiller unit. Within chiller unit, you maintain the syrup at a specific temperature. Syrup is a mixture of various components which gives you the desired taste. For example, when you consume Coke, it will taste in a specific manner. If you consume Pepsi, it will taste in a specific manner. Sprite, Fanta, all these things will taste differently. And they taste because of the syrup. And this formula, Coke, Pepsi, etc., they say that this formula is very unique. And then they do not disclose it to anyone, is what they say. But of course, it can be replicated. Anyway, so a chiller unit has to be maintained at a specific temperature. If it becomes hot, the syrup taste will change. Syrup has to be maintained at a specific temperature before it is diluted. Okay, only after diluting the syrup with water, underground water is taken and they mix it with syrup. Only then can you pour it in the bottles. So you'll have a unit called as filler unit. In this filler unit, if there is a PET bottle, say, for example, like this, okay, in which you pour some beverage. And then if you fill the beverage until the brim, meaning until here, if you fill, then the excess gas would ensure this bottle would get burst. This bottle would burst eventually, right? If it's filled until the brim. Or the moment customer opens the lid, it will just rush out because of the gas. Hence, you should not fill it until the brim. Neither should you fill it until here. If you're not filling it completely, then customers will be unhappy. Though it's a small quantity here, they'll be unhappy. So it has to be appropriately filled. Maybe until here, this is the appropriate, height of filling your syrup, which is diluted, of course. Only after diluting the syrup, you pour it here. So we have filler sensors which measure the height. If the height is until the brim or if it's until here, it is going to kick off this bottle. Okay, and from here, it will go to the packaging unit where it is packaged. Some sticker, some IPL, say IPL match is going on, they put that sticker. Some offer is going on, they put that sticker. And then they go into pallets, boxes, basically. And then from there to the distributors, and there to the retailers, and from there to the customers. Of course, that is all business process. So here within the manufacturing plant, you have a lot of machines. And machines have electrical motors also. And wherever you have electrical motors, more electricity is consumed. Then, after monitoring by analyzing the patterns of the data, the project has to give out some insights such as, hey, out of all these different units, different manufacturing units, this was a unit which was consuming maximum electricity. Or this chiller unit is all of a sudden consuming more electricity than what it usually used to consume. These kind of insights are gleaned from the data, and then alerts are supposed to be sent out to various stakeholders, various departments or various units. Okay, the scope here is the IoT-enabled monitoring of power consumption. It is going to help in deciding what are the various units which has to be run simultaneously, because you'll have X kilowatts of electricity which is given to the plant. How you use it effectively is left up to your discretion. So you need to optimally use it. So you can probably shut down certain machines when they are not in use. Okay, certain other machines you might want to run for more time. So all these kind of decisions are taken. Each motor and total plant power consumption have some relation. Okay, I mean, different units in combination are probably consuming more electricity. If you shut down one unit and then let the other units work, maybe less consumption would be there. All this will eventually help you in predictive maintenance. What are the manufacturing units which are overused? Will the machine fail? If the machine is going to fail, are we going to have the technician proactively go and fix it? Or do you have to replace some inefficient devices or cables? And proper load management. So ensuring that sufficient amount of electricity is given to each of the units. No unit should consume more. Simple. Here, the project goal was to reduce the power consumption. We had to reduce the total electricity consumed by the various components. So the objective was to monitor the electrical power consumption through IoT sensors, maximize the energy efficiency, and minimize the power outages and overloading. Okay, these two are extremely important objectives. You can have one objective or multiple objectives. You can have one constraint or multiple constraints. You need to secure the data. You need to ensure that the sensors are working well. You need to ensure that you have industrial grade sensors. These sensors, right, IoT sensors, which are usually used in manufacturing plants, undergo a lot of stress. Too much of temperature because of excess heat produced in the manufacturing plants, too much of humidity, too much of precipitation, right? It goes through a lot of stress, too much of vibration. If a machine is manufacturing something, it vibrates a lot. So there'll be a lot of vibrations. So all those things have to be taken into consideration. Otherwise, IoT sensors quickly fail. So you need to have someone who continuously keeps on replacing the IoT sensors. Okay, next. This is a crisp MLQ methodology, which we need to focus upon. Business and data understanding. Then you have data preparation or pre-processing. Then you have model building. You build the model. You test whether your model is good or not. That's evaluation. Then you deploy a model in production and you monitor and maintain your project. These two of late have become very, very critical, for successful completion of the projects. Deployment phase, monitoring and maintenance phase. So these two will give some special attention moving forward as in how we move forward. This was a technical stack which was used. From the programming language standpoint, we have used Python, which is a high-level programming language. Then from IDE, of course, you would not want to use Python software as is, right? Because that will just be a terminal. The look and feel is not good. You do not have a lot of options available. So obviously, you'll move on to IDE, Integrated Development Environment. When our team has worked on this, our past participants, when they have worked on it, they experimented with various things such as Spider, Jupyter, Google Colab, Atom, so on and so forth. Then these are the various libraries that they have extensively used: NumPy, Pandas, Python operating system module, Matplotlib, which is used for data visualization, SciPy, scientific calculations, right? Seaborn is advanced data visualization tool. sklearn or scikit-learn obviously has a lot of machine learning algorithms, stats models, etc. Then from deployment standpoint, when they have deployed this project in production, of course, Python has to be used. And then they have used Flask as a proof of concept. Then when they have actually deployed, when they have actually done the deployment part, they have resorted to Heroku. Okay, and then they have also used HTML, CSS, etc. for the beautification of the web page. We'll talk about all these things. We will show you live in action on what has happened. These are the various types of IoT sensors, just for your understanding, right? You can also use an RFID, which is basically one of the IoT sensors. You have temperature, force, whether water is leaking, oil is leaking, right? Electric sensors, which monitor the electricity, right? How much electricity is consumed, so on and so forth. These are the various sensors which are used. And you can judiciously think about what sensors should we use within the manufacturing plant. What are the sensors which are actually valid? Okay. Then this is what was used This is the exact screenshot of what our team has used, right? So it's a 3-phase LoRa, long range current sensor, means electricity sensor, and current transformer sensor. It also looks at the electricity coming from um, transformer. Because what happens is, if there is more electricity which comes, your sensor might fail. It might get burned out. So you need to ensure and regulate the electricity which is flowing in. Like you have your stabilizers. In that way, you have your current transformer sensors, which will ensure that the electricity which is coming into this device is of good quantity. Not good quantity. It is of permissible limit. Okay, and here is your project architecture. What happens is you'll have machines. You have installed IoT sensor, which I've shown in the previous slide. And that IoT sensor would capture the electricity which is consumed by this machine. And the IoT sensors were installed in various units, different units of the manufacturing plant. And the entire data was stored in this database called as influx database. Like you can also use MySQL. You can use Microsoft SQL. You can use Oracle database. You can use any database, basically. Any RDBMS database. And the team who has worked on this have used Influx database. Then you have something called as Influx DB connector, FLUX. Influx connector, DB connector. Right? From there, you take the data using this connector, you pull the data into Python, and then you perform your exploratory data analysis. Once you do your visualization and exploratory data analysis part, your data will be you'll be able to glean a lot of meaningful information. You'll be able to get a lot of meaningful insights. And then comes data pre-processing. Your data will not be in the format that you want it, right? You have to do a lot of changes. So you remove certain features, you handle the missing values, you look at the outliers, you treat outliers, right? You perform binning or grouping. And then you get the pre-processed data. Once you get the pre-processed data, you supply it to the phase where you actually build your model. You try out various algorithms, and here your target is predict the electricity which is going to be consumed in the future. Overall, how much electricity will be consumed is what you need to predict, given the inputs. Here you train, split the training and test data, you fit the best model, once you fit the best model, you evaluate it and deploy the model. When the model is deployed, you can use Heroku, which is a industry standard, one of the industry standards. Either you want to deploy it on cloud or you want to deploy it in some other location, right? But Heroku is an amazing platform. We will see practically also, we will see how it is done. Okay. A few things we'll do it today practically. And a few things will be switched over to the next week, next Friday. Yeah. So you predict the category of electricity consumption. So what happens is here, it's a binary business problem. You predict whether the electricity consumption is high or low. If the electricity consumption is high, then the technicians will go and see on why a specific machine is consuming more electricity. Okay. Why is it consuming more electricity? And then he will fix it. Is it by choice? Okay, by the design that machine is consuming more electricity, or is something going wrong with it? Is a specific component uh, experiencing wear and tear because of which more electricity is being consumed to run that specific component in that machine, more electricity is needed. We don't know, right? So as long as it predicts that the electricity consumption is high, yep, immediately a trigger is sent and then technician will go and fix it. Okay. So you can always argue that a simple rule-based engine can be there, right? For example, total electricity consumption is greater than specific value. Then I'll call it as high. Otherwise, I'll call it as low. Why can't I have this kind of a system? Okay. This kind of a system wherein if the electricity consumption is more than say 1000 kilowatts, then you say high. Less than or equal to 1000 kilowatts, you say low. This is called as rule-based system. This rule-based system does not look at correlation between electricity consumption of one machine to another machine. Because you have blower unit, you will have chiller unit, you'll have a filler unit, you'll have packaging unit, you'll have multiple units. And all of these have multiple machines. Is there a correlation between blower unit and chiller unit? Or is there a correlation between blower unit, chiller unit, and filler unit? If more electricity is consumed by blower, does that mean more electricity will be consumed by these two also? We never know, right? So for all these things, you cannot have a rule-based system. Hence, you need machine learning algorithm and AI application to solve it. Okay, next. So this is how the flow of process happens in this beverage plant. You might want to spend some time and understand how many horsepowers of power is utilized. Okay, for example, here this specific soft drink bottle filler machine, how much is it going to consume? 7 horsepowers filler unit for every 10 units per hour. So sorry, 7 horsepower is the machine capacity, and it uses 10 units per hour, 10 electricity units. Per unit, you will be charged, right? Electricity department charges you. Okay, that's how it is. So, I mean, of course, we need not spend too much of time on that. It's for domain knowledge purpose. Then the success criteria was defined, saying that electricity consumed for every unit should be decreased over a period of time. Overall production efficiency has to increase and your electricity consumption has to decrease. Basically, that was a success criteria. By doing that, a lot of money is saved, right? So you can also extend this to or this into 3 things. One is business success criteria, which is reduction in electricity consumed by different components. Then you have machine learning success criteria, which is accuracy, which includes 2 things. Accuracy of the algorithm that we are going to build should be maybe more than 80%. Some accuracy, right? Some success criteria you define. And also performance. What is the speed at which predictions happen? And finally, because of saving electricity, there'll be some cost benefit that is called as economic success criteria. Okay, these are the things that have to be mentioned. Source of the data was data coming in from IoT sensors. And we have set up an IoT gateway. You have all these IoT devices which connect to IoT gateway. From there, data goes into cloud, IoT cloud. It can be AWS or Azure or anything of that kind, or IoT specific clouds also exist. And from there, either you can view the results on the phone or you can view the results on your personal computer or a desktop, whatever you have in your office or your home, etc. These are the various variables. Data understanding is very important. So You need to understand what is the name of the feature that is input, and a brief description about that. This is also called as metadata understanding. Data about data. So descriptions about your variables. It's called as metadata. So metadata, what is the nature? Is it qualitative or quantitative? And then you have type of variable, nominal, continuous, etc. And then in this specific data set, data was getting captured every 10 seconds. Once in every 10 seconds, data was getting captured. And the data which was getting captured was energy. How much energy was consumed in watts, of course. So from kilowatts, in order to convert that into watts, you multiply it with, 1000, and then you divide it by 16 to 60, because this is hourly data if you want to convert that into minutes, and minutes if you want to convert into seconds. That's how you multiply. And here you're capturing every 10 seconds. So multiply it with 10. So ultimately you're capturing watts every 10 seconds. And then you anyways know the output variable, which is electricity consumption. Then exploratory data analysis was performed. Data visualization was performed. While the team here resorted to Python only, you can perform these two activities on business intelligence tools such as Tableau, Power BI, ClickSense, so on and so forth. There are various other things which exist. Okay, you can make use of these. Python also can be used. Binning or grouping the data. Then how was this done? Grouping on the output variable. Entire plant, across entire manufacturing plant, was electricity consumption high or low? Then timestamp column was removed because they're feeling that that's not relevant, because we are not forecasting anything. We are predicting. Okay, there were no null or duplicate values, so they were okay with that. Higher the horsepower, more was the electricity consumption. In that way, of course, they gleaned some meaningful insights. And they came up with various things, such as there was a machine called a CWT, which was consuming highest power, and the least power was consumed by some machine called as BBCM. These are all names of different machines across different units. So mainly the CWT, OC, and M13, HP19, right? These are the three machines. These are names of different machines, different units, rather. Okay, and then univariate analysis was performed. Univariate means single variable. You take a single variable, which is electricity consumption, and you do analysis. And when the distribution of the data was looked at from the output variable standpoint, a lot of components, or more than 50% of the components, were utilizing high electricity. If you look at this pie chart, pie charts are used only if you have 2 or maximum 3 categories. Otherwise, pie chart is considered to be the least preferred. Right? I would say if you have 2 categories, use it. If you have less than 2 categories, please do not use that. Okay, next. When it comes to modeling, our team has tried out various techniques. They directly used the output variable as is, which is the electricity consumed, which is continuous variable. They tried out in this way also. Then they converted this output variable into categorical variable. They made this high and low binary. And then they tried out decision tree, classification model, KNN model. Of course, you need to try out multiple algorithms, right? And then you do the evaluation. when a team has tried out, please remember one thing, that when you treat your output variable as continuous, if you don't convert that into categorical, then you measure the accuracy of your model by calculating something called as root mean squared error, or there is something else which is called as mean percentage error. I would say mean percentage error is the best bet. Okay. So we tried out multilinear regression, lasso regression, ridge regression. The team has tried out, and the various R squared values were here, but R squared values were very low. Usually your R squared value, if it is greater than 0.8, it's considered to be a strong model. Okay, here it is not at all strong. Then you have classification models in which people have tried out decision tree and KNN. Okay, so training accuracy, test accuracy was looked at, and you look at whether the accuracy values are close to each other or not. If it is error, you check whether the training error and test error values are close to each other or not. If they're not close to each other, that means your model is overfitting or underfitting, right? Here, when it comes to decision tree, high accuracy, and this amount of difference, less than 10% difference in training and test accuracy is okay. Then you can term the model as a right fit model. And yep, so among all these algorithms, decision tree was considered to be the best model. And people have gone ahead and they have deployed the model. These are the various model parameters which were used, or I would say hyper parameters. Entropy was used, maximum depth equal to 9. These are all algorithm specific hyper parameters. You can keep tweaking it and you can keep experimenting with different options and see which option is giving you the best result. Okay. And when it comes to deployment, our past participants who have actually worked on this under the guidance of our data scientists have used Python Flask as an experiment, proof of concept, just to visualize, okay, how should the look and feel be and all that. And they have improvised it using HTML and CSS. Okay. Just to ensure that the look and feel of the web page where the results are shown is good. And finally, they have resorted to, for the actual purpose, this Flask is only for proof of concept, just for you to understand whether the deployment part is working well or not, etc. And then when it comes to actual deployment, you deploy it on Heroku. It's a cloud-based application where you can deploy and run your application. And then you can integrate it with GitHub. So entire code was actually available on GitHub, and Heroku integrates with GitHub. So here you'll have your entire code base. And Heroku application will integrate with GitHub, pick up the code from here, and start running the model here. Okay, and you also have a provision to monitor that part. If okay, this is how the output would appear. These are the various inputs that you supply, and what is the minimum value and maximum value which is supposed to be entered is given here. And this minimum and max value, or these minimum and maximum values of each and every input variable that you're getting, is from your historical data. Your historical data on which you have trained your model had these as your minimum and maximum values. Okay. These were the minimum and maximum values. And then when you click on predict, you get the result. It will say whether the electricity consumption is high or low across the plant. and which machine is actually consuming more, and your, technician can go fix the issue, so on and so forth. So given these various inputs, this is an example of output, right? Given these various input values, when you click on predict after entering these inputs, you get the result that electricity consumption is high. It will send a clear alarm to the plant manager saying that, hey, plant manager, you are ending up spending more money on electricity. Please do something. So he would look into then each and every unit, see which unit is consuming more electricity, etc. Then, given all these various inputs, here the output was showing as low. Electricity consumption was low. Okay. So that's how the output was. And before I get into conclusion, there is a phase which is called as monitoring and maintenance. In monitoring and maintenance, we will demonstrate this probably next week. Okay. Some amount of code we will show you now. And next week when we connect, entire thing end to end in action. When I say in action, we will show you by running the code on how everything is done. So in monitoring and maintenance, there are three things that happen. One is called as data drift. One is called as model drift. And then you have something called as concept drift. Okay, you have all of these things. In data drift, what happens is your data might have different distributions. For example, maybe your one of the input variables was following a normal distribution. But eventually over a period of time, you observed that data became skewed like this. That means your distribution, when you deployed your model for a variable, was like this. And after say 3 months, the distribution became like this, skewed. You trained your model on this kind of data, but the new data is appearing like this. So what should you do? You have to retrain your model on this new data, where the data distribution completely changed. Because of this, your model accuracy will go down. That is called as model drift. Concept drift is the way you interpret the output. That in itself will change completely. These are the various reasons. I mean, say concept drift, for example, because of global warming, your machines are becoming hot, and because of which more electricity is being consumed. Could be. Because of that, output is changing. So the way you interpret the output also maybe eventually changes. So you might say that for my output, I'm going to add plus 10 units of electricity or plus 3 units of electricity because of various reasons, because of the wear and tear of the machinery. If the machines are becoming older, they'll start consuming more electricity. That is not included in your model. What is the age of the machine is not included in your model, right? So you come up with the rule saying that whatever is the electricity consumed, which my model is predicting, I need to add 10 units to it for every 1 year of aging of the machine. If the machine is old by 1 year, 10 units, add it. So it will consume 10 units more electricity than what is predicted. If the machine is 2 years old, let me add 20 units. In that way, you come up with some rules. So your concept drift also happens eventually. This is why retraining the model is very, very important. Why all this headache of adding some number, etc., when you can actually retrain your model with the new data. So retraining is extremely, extremely important. Next, we will look at practical stuff. I would ask our friend Madan to share the screen, and then I'm going to explain the code. Madan, over to you, please. Can you please share your screen and show the code? I just stop the screen share so that our friend shares the screen. Okay, please go ahead, Madan. Share your screen and show the code, please. Yeah. So we are showing you the code in Python, and we are using Spider IDE. Okay. Next week when we connect, we will show you how to connect your Python with influx database, and then how do you pull the data, how do you build model and all that. For now, we are just showing you in CSV5. So these are the various libraries that have to be installed and invoked. You need to upfront think about what are the libraries that would be needed. If you don't know, don't worry. Eventually, you will try to learn those things. So can you select all the various libraries and run it, please? And if you see line number 29, my dear friends, grid search cross-validation technique is employed, right? That is extremely important because you need to experiment multiple algorithms. You cannot, just like that, use the default values of a single algorithm. You need to experiment multiple algorithms. And purposefully, we have made a mistake here in line number 36 and 37. Coding best practice is not followed there. Just to show you that after the object name, there has to be a space and then equal to sign and then a space, right? Space and then after equals. And this is the best practice. Okay, so these kind of best practices are observed by the interviewers also. After you clear your first round of interview, usually the second round or the final round will be, they give you a use case and they'll say, I'll give you 24 hours, solve it. They look at all these best practices, whether you are giving comments or not, whether you are creating your code in different blocks or not. Okay, all these things are very, very important. Okay, now we will load the data set. Can you please load the data set? So we load the data set. You look at the head. Head is, can you run that? Next line. Head means it will show you the top 5 rows of your database. Then can you look at the shape? Line number 34. Shape will show you how many rows and columns are there. In interviews, they will ask you, what was the dimension of your dataset? When people ask you what is the dimension of your database or dataset that you have worked upon, you have to say, I had 18,000 rows, 11 columns in this specific example. Yeah. Can you move on to the next line? .info will tell you whether you have any missing values, right? What is the data type of each and every column? What is the overall memory which is utilizing? If you see the last line in the console, if a friend can hover the mouse onto that part, it is 0.5 MB, 1.5 MB, right? That much amount of RAM memory is being used. If you have 8 GB RAM, then only 1.5 MB is being used out of that. Yeah. Next line is, if you feel any of the columns are irrelevant, not needed, you drop off those. So saying, go to the data set, drop the column called types. Then you're doing exploratory data analysis by using this describe function. Can you just run that line 37? Okay. So describe, and we are storing that in an object. So if you double click and open that object called DASC, you have the count overall, how many values do you have? You have the mean, standard deviation, minimum value, max value, so on and so forth. Can you close it? And then there is something called as pandas profiling, which will actually help you perform auto exploratory data analysis. Automatically does your EDA. So can you please run that and then show the output? So the output would appear in HTML format. We'll wait for that to complete. It will do a lot of amazing analysis. Let's just wait and watch. It's taking a while. That's okay, because it's doing a lot of analysis automatically for you. While it completes that part, you can check whether you have duplicate values or not, whether you have null values or not, by looking at the code from line number 46 until 50, 50, right? That will actually help you, figure out whether you have missing values. If you have missing values, you do imputation, and duplicate values, if you have, you might want to get rid of those. Yeah. Now that is done, profiling, can we showcase output.html file, please? Just to show to our audience on how that particular file appears. Yeah, so we are opening that file, friends. Just give us a moment, friends. We are opening that file. So, Madan, yeah, good. So here is that specific file. This is how it appears. What are the various variables, observations, right? How many of them are numerical, total memory, how much is it using? And a bunch of things such as for each and every column, it shows you what is the data distribution that it follows, right? How much memory is each one following? And then what is the correlation of that variable with others? What is the statistics? Look at that, interquartile range, skewness, kurtosses, you get everything. Common values, extreme values are like outliers basically, right? So you get to see a lot of things. What is the correlation of a specific variable with other variables? How many unique entries are there? All of that. I mean, this is an amazing analysis, right? When it comes to profiling. What variable is correlated to which other variable? You'll see scatter plots, correlation coefficient values, Spearman's correlation coefficient, or Pearson's or Kendall's value, so on and so forth. And if you scroll down further, you'll have missing values if you have any. Scroll down further, please. Yeah, here is a sample, the first set of rows, first 10 rows, just for you to have a glimpse at it. Then the last rows here. So these are the various things that we have. We have auto EDA, a few other libraries but this team has chosen this pandas profiling option. Yeah, can we move on to Spider? Then we can look at whether we have missing values or not by running line number 47. So there are no missing values. If you look at the right side pane, P-A-N-E, that's how you pronounce, you call, right? Console pane, everything is appearing zero. Can you hover your mouse over there, friend? Yep. So we have everything as zero. That in itself means that there are no missing values. Can you do it for duplicate? Let's see how many duplicate values exist. And then you stored it in an object called C. Then you can see here, you can just run the next line of code, please. C dot value counts. So there are 18,000. So there are no duplicates. Those many rows are there, but there are no duplicate rows. Well, good. If there is duplicate, remove it. Doesn't make sense. Okay, then you can calculate mean, median, variance, standard deviation, all this exploratory data analysis. Already we have done it as part of .describe, but just in case if you want to run, you can. You need to do it for each and every variable, and then you need to sit down and analyze and think about why you got a specific value over there. Okay, beverage is the name of the data set. If you say beverage.mean for the entire data set, you'll get the averages. If at all you have numerical values. Can we move on to the next thing, which is finding outliers? Line number 82. Yeah. So this is how you find the outliers using box plot. And yep, there is this box plot. And yeah, you can look at that, and then you have a bunch of outliers that exist. All plant means for all the various units in the plant, like blower unit, chiller unit, filler unit. For each and every unit, all those units are given on the x-axis. On y-axis, you have each and every machine and the electricity consumption, etc. And you have quite a few outliers here. Can you close this? You obviously need to analyze those outliers. Duplicate, we have already looked at that. Yeah. Can you look at outlier treatment and what we do usually when we have outliers? Can you select line number 96 until 100? And yep, go ahead with 101 also. Yeah, and run it. So if you look at the trimmed data set, what we have done is actually whatever outliers we have, we have removed them. If you look at the console output, earlier we had 18,000 rows. Now we have 17,924 rows. So all those different other rows, for example, I think close to 76 rows have been deleted, trimmed. I mean, that's your choice. If you feel you want to replace those, replace. Okay, so that's what the team has done. I'm sensing some analysis was done, and then they figured out that nothing can be done, but we need to remove those. Okay. Yes. Can you run now the box plot chart after removing the outliers? For each and everything, you can check, and there seems to be no outliers. One is just about there, but then that's okay. You can close this, please. Or you can replace, right? You can replace the, outliers with upper values, right? This is called as, usually people call this as winsorization technique. Yep, you can run this. Line number 109. There we go. So those two things which were appearing as outliers, right? Just about outliers are also gone now. Yep. Now, can we do a pay plot? We can look at missing values, line number 114. Whether there are any missing values now or not. Seems like there are no. Fine. We'll move on now. We can do a pay plot. This pay plot will show you the correlation between all the variables onto all the other variables. It's taking a while. We will wait and see when it's going to pop up on the screen. Let's see. Maybe it will take some time. It depends on your computer configuration as well. Yeah, there we go. Far too many things, quite clumsy, not able to glean any meaningful information from this. At least I cannot. So maybe you can close this, and maybe visualization need not always be a good way, right? So what we can actually do is, in this kind of scenario, you can look at correlation coefficient matrix. There you'll have numbers, correlation between different variables, and that would actually make more sense. Yeah, can you please run the heat map once? Yeah. So this gives more meaningful information, right? As opposed to that visualization. Here you have all the correlation coefficient values. Actually, not many variables are correlated with the output variable, which is all plant electricity consumption. So that's okay. You can close it. So there's only so much that you can do, friends, with the data which is given to you by the client, right? If the data doesn't have correlated variables, that means output and inputs are not correlated, then of course you will not be able to build a model with very good accuracy. But a good data scientist is that person who does a decent job with very bad data as well, right? So we'll stop here. It was a 1 hour session. And from here on, we will continue next Friday. Every Friday, we will have from 6 to 7 these sessions. Please subscribe to our YouTube channel and click on the bell icon so that you are notified when that session happens. And we will also show you live demonstration on how data is picked up from the SQL server into the Influx database, into Python. From there, how we build the model, how we deployed the model on Flask, and also how we have leveraged Heroku to do the deployment. Everything practically you will see next week. Okay. Thank you all so much for watching. And it's really a pleasure interacting with you all. I hope to interact with you all next week as well, next Friday. Thank you, friends, and have a good day.